the message that we can do something very meaningful in our lives, like the hummingbird. And now we're going to start and show you some very, very simple toys. Now I'll start with the electric motor. All of you, it's part of the curriculum, 9th to the 10th class, you've got to make an electric motor. Very few children make the electric motor, but it's actually very simple to make one. This is a new battery. These are two safety pins. This is old bicycle tube. It's difficult to buy broad rubber bands, but there is a word which India has given to the world and which is called as jugaad. If you don't have some equipment, apply your mind. And you will find a substitute, you will find an alternative, a much cheaper alternative. So this is an old bicycle tube, and both the safety pins are snugged with the plus and the minus of the battery, 1.5 volts across this. This is a ferrite magnet, a very, very simple magnet, ordinary magnet, a very weak magnet. And this is a small coil. Now this is the simplest motor on earth. If you have the battery, it costs 5 rupees to make a motor like this. So it's not a rich man's game. And it takes less than 10 minutes to make a motor. Now this part you understood very well. This is very easy. 1.5. If you were to attach a small torch bulb, it's going to glow. Not burn very brightly, but glow because 1.5 volts. You take 1 meter of insulated copper wire with a varnish on. There is copper inside, but a varnish coating it. A meter, and just tie it on an old battery. You'll get about 10-12 turns, remove it like a slinky, like a spring, and then tie one knot here and the other end here. They should be diametrically opposite. If I put it right now, no current will flow because this is insulated copper wire. It's got a layer of varnish. And what we have done is, and this is the significant part, scrape one part completely and you'll see shining copper. One side is all copper. On the other side, you scrape the top, the right and the left. 3 sides you scrape. But only one bottom is the insulation. So whenever the copper is in contact, current flows through the coil. Once the insulation comes, it's switch off. On off in every rotation of the coil. And this acts like a commutator or a brush of a DC motor. If we were to scrape all of it, then current would flow through this coil continuously and would become a permanent electromagnet, which will have a north and a south. And the north of this will be attracted to the south of this permanent magnet. They will align and they join hands, say bye-bye. No more rotation. But at that junction, what comes in? The insulation. Current stops flowing through the coil. It's demagnetized, but because it was rotating, there's still some momentum. It still rotates a little bit. Once again, the copper is in contact, makes it electromagnet. The north of this is attracted to the south of the ferrite magnet, and the north of this is repelled by the north. This is how every electric motor on earth works. We have made 100,000 motors with children and teachers, and they're surprised how simple this is. And children can do a series of experiments with this. That you bring another magnet on top, what happens? Instead of 1 meter, have 2 meters of wire, 4 meters of wire, half a meter of wire. Put another battery in series. Change the air gap. This is very crucial. The air gap between the magnet and the coil, and see what difference it makes to the performance of the coil. And this is how children learn science. This is the process of science. And well, you might have seen the motor, but very few children have ever made a generator in their lives. Now this is a model of a very, very simple generator. Medical technology. We live in a world, it's a consumerist society. Buy and throw is our credo. So there are piles of junk. Medical technology throws away a hell of a lot of junk. Literally millions of syringes are thrown away. This is just the plastic part of it. We have nothing to do with the needle. Now, these are 2 strong magnets called as neodymium magnets. If you look at the periodic table, like Fe stands for iron, Nb stands for neodymium. Now, this is an element. And these are such strong that you can't separate these magnets. And in the barrel of this syringe, you put these magnets so they are freely, they can move freely. It's a small piece of rubber which is like a stopper. So this part is very simple. Then you take thin insulated copper wire, about 36 gauge. The more the gauge of the wire, the thinner the wire is. So about 1,000 turns. And because both the ends would be insulated, you scrape the insulation so that the copper is exposed and attach a small LED. That's all. Entire time from start to finish is half an hour. And you see, now I'm going to move the magnets inside the coil and see what happens. Now this is magic. This is how you produce electricity. You know, imagine a child in class 7, class 6 making a generator like this. This would open up their minds. You know, Faraday's laws would stand out in much deeper clarity. The equations would start making sense. Because, and you're not a consumer now, you're a producer. एक बच्चा जो आज एक एलईडी जलाता है कल अपने गांव को रोशन करेगा, उसका दिमाग खुलेगा, कल्पना शक्ति बढ़ेगी. And this is not a rich man's game. At least 10,000 children in class 7 have made this generator. Very, very simple. I'll show you another model generator. No, there are, you could take a Teflon. You know, nowadays plumbers use this, this is Teflon tape. If you want to attach a tap to a pipe, earlier they would use some jute and some white paint. Now they use Teflon tape. This is the empty spool of the Teflon tape, 1,000 turns in the LED. This is my electrical circuit. At the cover we put two paper clips, put tape around them, and this is my 2 magnet spin. This is my magnetic circuit. Separately they do very little, but if we bring them together, well, you can see this is the coil, and the magnets will rotate at right angles to the coil. And if we do this, at the spin of your finger, there is no battery inside. You would also realize that they're not connected in any way, because magnetic force is a very powerful, invisible force. And you would realize, you get a feel for these forces only by messing around and playing with them. Well, another variation, you can do this. You can see these 2 magnets spinning inside. We have a crank generator. You can see these are the 2 neodymium magnets. This is a bicycle spoke, and here is a tape recorder pulley. First 1, 2, 3. How to make a larger pulley? Well, take 2 old CDs and sandwich a circular disc of cardboard inside this, and you make an improvised pulley. This is the Indian jugaad. It's difficult to buy a big pulley, but you could improvise one. And if I turn the handle, this is going to turn once, this is going to turn several times. And the magnets will be spinning inside this coil, 1,000 turns, the ends are attached to LED. And this is a crank generator. Very amazing generator. Very, very doable stuff. And something which would inspire children to take up science. Well, this is the variation of the same thing. You can see 1,000 turns and a LED, 1,000 turns. These are separate 4 coils with an LED. And you can see we have taken an old DVD, CD. These are 4 disc neodymium magnets. And there is a toothpaste cap, as you can see over here. There is a small gap in these 2. If I spin this with my hand, the magnets will be spinning close to the coils, and you see that. You make a multi-generator. Over 1 to 4 and 4 to 40,000, and you can just go on and on. This is how the whole world is lit up. But this is how children must learn their science. And well, we're going to demonstrate to you, but we have 150 experiments to do with old plastic bottles. In the US, which is the worst polluter on earth, 1 billion bottles are chucked away every single day. Such a shame. We are following the worst of the West. This is the worst of the West. So we took this as a challenge. IUCAA recently had a seminar, and everyone loves a good seminar because we collected 1,600 old bottles. We the recyclers to IUCAA. All right. Now, you can just cut up a bottle and make this extremely nice propeller. And, well, there is no fan over here, but if I were to, can you see this? In a breeze, it's propellable, and magnets are spinning inside the coil. And this is the future of energy. If you were to travel from here to Satara, you would see a lot of wind generators generating electricity straight away. And this is what every small child can make. Well, this is a very, very nice sound experiment. We're just going to take a straw. But not a very stiff straw, or neither a very soft straw. This is a kind of a medium stiffness straw. I flatten one end, and then with the scissors, I'm going to cut two slants, one slant on this side, one slant on the other side. I make a kind of like a pointed pencil. It's like a spear. And if I look from the side, it looks like a baby crocodile's mouth, as you can see. It's like a baby crocodile's mouth. And this becomes a reed. I'm going to put this reed in my mouth and blow my lungs out, and something extremely nice happens. It's a terrific way to make sound. We read about this. For production of sound, we require vibrations. We read this in our book. And it just remains a sentence in the book. But it can become a lot of sense. Now I'm going to keep this outside. The reed, which was actually producing the sound, was hidden in my mouth. And now this is outside. And now what would I do? Will I suck in air or will I blow out air? Suck in air. Just please see this, what's happening over here. And what I can do now is if I just make one or two holes, what am I trying to make? थोड़ी बेसुरी है पर है बांसुरी. This is how a flute works. You can produce a lot of notes from this. And this is a very, very nice experiment. What we've done is we've taken the same straw and cut a reed once again, soften it slightly, and this is an amazing experiment. I'm going to put this reed in my mouth and blow out, keep making the sound, and what I do, simultaneously I keep cutting the straw and making it, something very amazing happens. You've seen that the longer the straw, the shorter the pitch. The lower the pitch. And what happens is I cut it, the pitch becomes higher and higher. And with the shorter straw, which is this, you get a very, very high pitch. And this is something which children taught us, and if you learn nothing else in this workshop, but just this is okay. So enjoy it. Sounds like this. When it comes down to straws, you can do some very, very nice experiments with straws. Take an ordinary straw, and this is the ordinary straw, and I just take a thick broomstick and I just poke it in the center. Then I leave about 2 finger widths to the right, make a half cut, another half cut to the left. So you can see that both these arms can swivel, and then I bend them in the shape of a triangle, take some sticky tape and tape it around. And this is what we've done. We've used red tape, transparent tape, you'll not be able to see. It's a 2-minute tone. That's it. Now if I put this in a glass, in a mug of water, and I just spin this, something amazing happens. It's an amazing experiment on a hot summer day. It cools down heads. And this is a wonderful centrifuge. You know, all these are very abstract concepts, centrifugal force, but the children, if you can concretize them, show children these concepts in a toy, they're less threatening for children, they're much more likely to understand them. So this is a centrifuge, a brilliant centrifuge. Imagine children of class 2, class 3, watering small plants with this. They have great fun with science. Where we make lots and lots of pumps, and this is another pump. First I'll show you what this pump does. I've got a balloon, and this is a very, very nice pump with which you can inflate. It's a real one. And you can dissect the entire pump. What is this pump made of? Now what you do is, see this is the film can, and what we've done is, this is through which the air comes out, and what we have done is, we have just put a small flap. Can you see this flap? This is like a valve. This is green light, this is red light. This is go, this is stop, this is one-way traffic. So this is my delivery valve, and you see, on this bottle, can you see another flap? This is my suction valve. So this, if you can inflate a balloon with a pump, it's an extremely high quality pump. It's the ISO certified pump. No two doubts about this. And there are no glass parts in this. There are two film cans and a bit of old cycle tube. And you get a feel for a pump which nothing on earth can give you. He's just going to show you a film pump. This is our website, arvindguptatoys.com. We have documented 1,000 projects like this, science models, and you would see this documented in photographs, and there's also a film of this. Now this is a kind of a corrugated pipe. You might have seen this at the base of a sink, or even some electrical conduit wires going through this, because this can bend. And this you can buy in a hardware store. Now one is that I can just blow on this, and I can suck. Now the corrugations make the air to vibrate. And if I nice, right? You could do this, and suppose if I just close one end, that this is because of the plate. If I close one end, nothing happens. All right? So there should be a flow of air. It's a very, very nice experiment. Do at home. Now this is something called as a flexagon. It's called as a hexaflexagon. This is designed by a mathematician at Harvard in 1928. Very well documented by Martin Gardner in similar physics. Martin Gardner used to collate a math puzzle for the Scientific American, and he did this for 25 years. And all these puzzles now appear in 7 books. And this is the mind of the greatest math puzzles. So there's a whole chapter devoted to hexaflexagons, designed by Arthur Stone. Now here's a piece of paper which you can flex. You see butterflies right now, then frogs, snakes, eagles. Butterflies, frogs, snakes, eagles. Butterflies, frogs. 4 pictures which come in a sequence one after the other, and there is a story woven in these 4 pictures. And which is very easy to decipher, because this is like the food chain, because insects are eaten by frogs, frogs are eaten by snakes, snakes are eaten by eagles. It's like a food chain. And this can be made with a piece of old photocopy paper. You just have an A4 size Xerox paper. No glue, no scissors. You just need a piece of paper like this, a scale, and a pencil. And in 3 minutes, you can make this flexagon, and this is it. Very amazing. So you could be in a government school, in a municipal school, in a village school. All you just need is a A4 size paper, a scale, and a pencil. And in 3 minutes, you can make this. And we're just going to show you a little film of this. This is the most amazing rotating paper model. You require a A4 size paper, a scale, and a sketch pen. Take the A4 size paper and fold this into half, and then fold a triangle. Tear off the rectangular strip, and you will get a big rectangle where the length would be double that of the width. There will be 2 squares side by side. Fold the midline along the length and both the edges along the midline to get a long doubled up parallel strip. This strip has to be folded into 8 equal parts. Fold the edges to the midline to get the quarters, and then the edges to the quarter lines to get the 1/8. Then take 1 edge and crease it to 1 fold to get the quarter lines. This way you will be able to divide the strip into 8 equal parts. Then take the strip, fold this into half with the open ends exposed. Mark all the 4 middle points to make a diamond shape or a rhombus. Then mark the opposite corners or the two diagonals, and this shape looks like a horoscope, easy to remember. Make another similar shape on the other side. Now with the scale, crease very clearly all the 10 slant lines. 5 to one side and 5 to the other. This will be the final crease model. With the scale, tear off one section. Take this end and tuck it in the pocket of the opposite end. We have torn out one section and tucked one. So we have got rid of 2 and only 6 sections remain now. With these 6 sections, we make a very nice prismatic shape, a kind of a triangular roof. This is a triangular roof. And you can see that there are half diamonds on both the ends. Fold these half diamonds inside, first in the first section, then fold the half diamonds in the second one, and finally on the third one. Having folded the half diamonds, you will see a kind of a hexagonal shape with petals on the top and the bottom. Crease these petals inwards, and the flexible is almost ready now, and you can rotate it. It's amazing that you can rotate paper without the paper tearing. It's a great surprise. You can also make a food chain. Draw insects. Insects are eaten by the frogs. Frogs are eaten by the snakes. Snakes are eaten by the eagles. This is a very nice food chain.